Dear friends, architects, engineers, and consultant engineers, this particular and my dear students, this particular slide and series is on integrated electrical lighting circuits. Once again, welcome once again to VK Jan Sir ki MEP classes. Now in most of the architectural colleges, they are teaching MEP services, and in that also they have integrated electrical lighting circuits. This is a important subject as far as electrical branch is concerned, but for master's degree architectural courses they are teaching integrated electrical lighting system in architecture as well as in designs, that means interior decoration. So we'll learn about this. The integrated electrical design may include from man receiving station, substation to main switchboard to TP and DV, and then circuit wiring and point wiring. The whole essence of electrical wiring system starts from main receiving station in big campuses where the load demand may be more than 10 MVA. So we have a main receiving station where we receive the electricity, and thereafter it is distributed in the campus through different substations. This diagram shows 5 substations. Friends, a electrical substation is the most important place in the entire campus as far as electrical services are concerned. Now, this particular diagram shows a substation having two transformers. Uh, we start from this point through double pole structure to be shown in some of the slides. We get electric supply company, electrical supply from electrical supply company, and which is first metered in a meter room. The meter room has to be having clearances of 2 meter in front of the ST panel. The the ST the from this has to be enclosed for metering purpose, and the this remains closed because it is under supervision of electric supply company. From here we go to ST panel. The ST panel may be something consisting of several panels. One, it is equal to number of transformers, that is 2 transformer and 1 incoming. So this will occupy space for 3 panels, each of 800 mm. That means the total length of the panel will be about 2.4 meter, and we have to leave a space of 2 meter in front of the ST panel. From the ST panel the supply goes to the transformer number 1 and once again to transformer number 2. each substation is located about 300 mm above the highest flood level in plan, and each room is provided with a ramp so that heavy equipment can be taken inside. There are several ramps in the substations and in both the sides. Uh, this side and the other side opposite to it. We have got several ramps. Now, the secondary side of the substation contains medium voltage supply, which is connected to LT panel, which is known as MV panel also. And this LV panel gets supply from generator as well as through transformer through AMF panel. It may or may not have petrol, oil and lubricant store, and WC and toilets are provided for convenience of the staff, and the staff is sitting here. Dear friends, the most important part of a uh, electrical substation is the transformer, and the transformer is meant for changing voltage level from 11 or 33 kV to 433 volt, the medium voltage. That medium, this is the primary side uh, winding contained in this tank, and when the winding gets hot, it is filled with the transformer oil, and when the transformer oil leaks up, it is provided with a local transformer oil tank for making up the oil level. The oil gets heated up, and for cooling it, radiators are provided, which increases the surface area uh, for cooling air to cool the transformer oil. The transformer has got a oil conservator, which is here, oil conservator here, to make up, which contains makeup oil, uh, nearly 100 liters. The transformer is supported over the rails, this one and this one. This particular slide shows vacuum circuit breaker on 11 or 33 kV side, which may have LT panel also, as shown here. LT panel gets supply either from transformer or from generator, and through several switch fuse units or MCVs or MCCVs, it supplies air to other parts of system. This may contain busbar on the top and cable alley for taking in or outgoing cables. The bigger size of this may be MCV, MCCV, or it may have a switch like air circuit breaker as well. This slide contains different type of switches. We have 5 or 15 amperes, 5 ampere switches like this, and 15 ampere or 16 ampere switch like this. This switch controls a circuit. The circuit will have several terminals, uh, positive and negative, positive and negative in short distance, and earthing terminal. Previously we used to have ironclad three-phase switches known as rewirable or HRC fuse type of switch fuse units, but currently we are using single pole miniature circuit breaker. It may be double pole for breaking both incoming phases. We may use three pole TP and MCB for motor circuits, and for three-phase circuit we may use the triple pole and neutral. All all phases gets disconnected through this type of switch. These switches are up to 63 ampere or for dealing 40 kilowatt of load, and if the load is more than 40 to 400 kilowatt, then we use MCB, miniature circuit breakers of different types. Friends, for bigger campuses, we get electric supply through overhead transmission line, maybe 11 kV, and in that case, the electric supply comes like this. This is a double pole structure. Two poles are there, and on that some extension the transformer is provided, and transformer will have protection circuits here. So this shows the elevation and this shows the end elevation. This is used for getting supply up to say 400 kilowatt or so. Friends, in case of medium voltage or low voltage supply to a residential unit, this is the residential unit. We take electric service connection from electricity board through overhead structure, and it comes to inside of the residential unit where it is controlling the electric supply to the residential unit. Residential unit get single phase supply up to 5 kilowatt, and above that it always required to have electric supply in three phase. So inside, in case of big campus other than residential, we have overhead busbar circuits which are horizontal, but they are at certain height hanging from the ceiling. It may be false ceiling, above false ceiling, and then the vertical portion of electric supply is taken to several floors through a circuit known as rising man. These are all three-phase circuit. We get electric supply here. It is distributed overhead and brought to some motor circuits. It is once again taken to other load circuits here and here, and vertically it is taken to different floors through a main floor switch. Friends, for various defects or faults in the electrical distribution system, we have some other apparatus to be installed. We use other type of residential current operated circuit breaker and resident current operated voltage operated circuit breaker and otherwise residential current device. Friends, the integrated electrical supply system consists of type of lighting illumination lamps. I have described several type of lamps here and their color rendering index. This property is very important because for reading purposes we always need at least color rendering index of 85. The daylight is having 100 CRI and the other lamps are compared with respect to this daylight outside. The most efficient lamp in past days was T5 lamp, which came in 14, 21, 28, 35 and 55 watt category, having current rendering index, and this was most recommended lamp unless as compared to LED. LED is not having proper color rendering index. We have another lamp series which is known as fluorescent type TLD, 18 watt, 36 watt or 54 watt, having good color rendering index. Then we use metal halide lamps in 35, 70 watt series, giving a color rendering index of 84. Metal halide lamps are used in outside illumination purposes, mostly for cricket and football matches. Metal halide lamps are also available in lower category, 10 to 40 watt, and having the best color rendering index. Metal halide of 35, 70, 150 and 25 watt are also having good color rendering index. Recently, in the past 5 years, LED light emitting diodes have been used, of which the category, which is costly, is having color rendering index of 80 to 90. Then SON, this is sodium vapor, high pressure sodium vapor lamp, which has a very poor rendering index, and the most efficient lamp, low pressure sodium vapor, is having even worse color rendering index, but these are used only for yards, bus depots, railway yards, this metro yards, similar where a person has to remain for very short time. LP, low pressure sodium vapor lamps, has a single monochromatic color rendering possibility, under which a person feels madness if remains for a longer period, more than 15 minutes. That's all. I express my thanks to all the persons which have seen this series, this module on internal integrated installations, a course which is being taught in master's degree of several architectural colleges.